Good morning, students. In this video, I'm going to explain about average depth of precipitation. One rain gauge station cannot represent a large basin, so a basin is always composed of many rain gauge stations, which are evenly distributed throughout the whole basin. Again, the amount of rainfall may not be equal in all rain gauge stations. So, in order to compute the average rainfall over a basin or catchment area, the rainfall is measured at a number of rain gauge stations suitably located in the area. The network density of rain gauge depends upon the uses for which the rainfall data is intended. A network should be so planned so to have a representative picture of the real distribution of rainfall. There should be no concentration of gauges in heavy rainfall areas at the expense of dry areas or vice versa. Since the average rainfall of the basin is required for estimating the runoff from the basin, it is customary to apply any suitable method to determine the average depth of precipitation. The following the three methods are generally adopted to calculate the average depth of precipitation. The first one is the arithmetic mean method, and the second one is Tyson Polygon method, and the third one is isoheital method. First one is arithmetic method. In this method, the average depth of rainfall over an area is obtained by dividing the sum of the depths of rainfall recorded at all the rain gauge stations located in the area by the number of stations. Thus, if P1, P2, P3, n number of points are the depths of rainfall recorded at the n rain gauge stations distributed over an area, then the average depth of rainfall P for the entire area is given as P is equal to P1 plus P2 plus P3 plus P1 P4 uh, and Pn whole divided by n is equal to summation of P divided by n. The results obtained by this method will be correct only if the rain gauge stations are uniformly distributed over the area and the rainfall varies in a regular manner. This is so because in this method every rain gauge station has equally weightage regardless of its location. Second one is Tyson Polygon method. In this method you can see the rain gauge stations points are connected in the form of the polygon. That's why this is called as polygon method. This method is used for non-uniform rain gauge network by assigning weights to station data in proportion to the space between the rain gauge stations. Thus, the method simply assumes linear variation of precipitation between the rain gauge stations and assigns equal segment of the area to the nearest station. Tyson polygon method is a more common method of weighing the rain gauge observations according to the area. Tyson polygon method is also called weighted mean method and is more accurate than the arithmetic average method. So procedure, what is the procedure for the average, calculating average? So first join the adjacent train gauge stations by straight lines. Second is construct the perpendicular bisectors of each of these lines. Third one, a Thyssen network is thus constructed. The polygon formed by the perpendicular bisectors around a station encloses an area which is everywhere closer to that station than to any other station. Find the area of each of these polygons. Fourth is multiply the area of each Thyssen polygon by the rain gauge value of the enclosed station, encoded station. Fifth is find the total area, that is summation A of the basin. Sixth is the compute the average precipitation or rainfall from the equation. The equation is P average is equal to A1 P1 plus A2 P2 plus A3 P3 plus dash dash AN PN whole divided by A1 plus A2 plus A3 plus dash dash AN is equal to summation A into P whole divided by summation A, where P average is equal to average depth of rainfall in the basin. P1, P2, P3 and number of points is equal to rainfall depths at various stations. A1, A2, A3 and AN is equal to area surrounding the rain gauge stations. And in the next video we can see the third one, isohydral method. Thank you.